Hey everyone, welcome to Code Harmony. Today I'm going to solve LeetCode problem number 1072, flip columns for maximum number of equal rows. In this problem statement, we are given a matrix of m cross n size. That's all we are given, and we are asked to perform this operation over the matrix. And what is this operation? You can choose any number of columns in the matrix and flip every cell in that column. Flipping every cell means if it is 0, make it 1. If it is 1, make it 0. It means that cell is going to have a binary value, either 0 or 1. Also given in the problem constraints. Here you can say this is a particular example, and what we have to return is the maximum number of rows that have all the values equal after some number of operation. So what is our operation? Our operation is something that choose any column and flip all the digits or all the cells in that column. Let's say if I choose the 0th column, I will make the 0th column as 1 1 0. So this is our operation, and after making this operation I need to return how many rows are having all the values equal. So this is our problem statement. If I try to run this over this example, what we need to know is maximum number of rows which are having equal values after we have performed some number of times the operation given in the problem statement, that is flipping every cell of a column. Let's say if I flip the first column, the first column will become 1 1 0, and the second column and third column will remain the same. And after our operation, how many rows are having same values? No row is going to have same value. It means here answer is 0. So flipping the first column will not make any good impact. And now let's try to flip the second column. If I flip the second column, grid will look like this. First column will remain the same, second column will look like this, and third column is this. Even after this operation, even a single row is not having all the same values. So answer is 0 in this case. So this is also not going to give us a good answer. Let's try to flip the third column. If I try to flip the third column, first two columns will look like this, and third column will become 1 0 1 1 0 1. Now we will see that the second row and third row are having same values. So here I can say that my answer is 2. Not the answer, the candidate to my answer is 2. And we need to perform or figure out all the combinations where we can get this answer, and we need to track the maximum answer among this problem. This 2 is the candidate of the answer, and we need to check all the possibilities, like where we will perform any number of operations, and then we need to see what is the maximum answer. An answer is the number of rows with same values. So here in this case, if I flip the third column, I'm going to get 2. If I try to see that, and there can be the possibility when we do not flip any column, that is also fine. If I do not flip any column, then the first row is going to be my answer. Like the first row is having all the values same, so 1 can also be the answer. So here I think I'm not able to get values more than 2. So I will return 2 from my function. Here in this problem statement, if we try to analyze this flip operation, when we flip the third column, then I got 2 as my answer, and these 2 rows are having the same values. If we try to have a look on the values of these 2 rows, they are in the opposite form. The second row is having 0 0 1, and the third row is having 1 1 0. Okay, they are already opposite to each other. As per the problem statement, we need to make all the values of a row equal, and we have 2 possibilities, either 0 or 1. So what are the possibilities of a row to be able to get into the answer? So the row values should be either all the 0 or all the 1. Can you think of any other option? No, I don't think. There is only 2 possibility, if I have to make all the values of the row equal, it should either be 0, 0, 0 or all the ones. Okay, so here if I try to make the second row a valid row means if I try to make it 0, 0, 0 or 1, 1, 1, in that case all the rows which are already equal to this row, those will definitely be converted to the valid row, and all the rows which are opposite, which are currently opposite to the current row, those will also be the valid rows. What I'm trying to say is that if I try to make 0, 0, 0, 1 valid, so there can be two possibilities. If I make it 1, 1, 1, if I make it 0, 0, 0. If I make it 1, 1, 1, all the rows, so there can be the situation then when I am encountering 0, 0, 1 row multiple number of times. So if I make this row a valid row, then all the instances similar to this will also become the valid row. Let's say this row is coming 5 times and I'm making it a valid row, then 5 is already added to my answer. And if I look at the opposite row, rows which are opposite to the current row, let me see this. If I try to make it 1, 1, 1, it shows that I have flipped first two cells. If I flip first two cells, it will become 0, 0, 0. When the first row will become 0, 0, 0, in that case I have flipped the third cell. So third cell if I flip, it will become 1, 1, 1. So it shows that if I try to make a row valid row, then the opposite row will also become valid. So let's say this row is coming 5 times in my grid. This row is already 5 times in the row, and the opposite row is coming 2 times in the grid. Then I can directly say that if I make this row valid, answer would be 5 plus 2, which is 7. Or if I try to make this row valid, answer would be 2 plus 5. Okay, so this is the core of this problem. I need to make rows valid, and if I need to make rows valid, it should be 0, 0, 0, it should be 1, 1, 1, and I can check with every possibility. It means I can iterate row wise and see if I try to make first row valid, what is my answer in that case. If I try to make first row valid, it's already valid. It means we don't need to perform any operation. So the answer would be 1. How many rows which are equal to this? No other row is equal to this and no other row is opposite to this. So 1 is my candidate. So if I try to make second row valid, it will become either 0 or either 1, 1, 1. Whatever we try to make, I will do the same operation. It means all the rows which are already similar to this row will also be valid, and all the rows which are opposite to this will also be valid. So here no other row is similar to it, and there is one row which is similar to it, which is opposite to it, sorry. So the answer would be current row is coming 1 time and opposite row is coming 1 time. So two rows will be valid if I try to make first row valid. Now if I try to make this last row valid, this row is coming 1 time and opposite to this row is coming 1 time. So 2 rows will become valid if I try to make it valid. All of these are my candidate and no other candidate can be out of it. And because why? So if I try to make let's say if I try to make this valid, so all of the other rows will become disturbed even if they are already valid. So if I make 0, 0, 1 valid, all of the other instances, let's say 0, 0, 0, they will be invalidated and they won't be counted as in my answer. So I hope this approach is clear to you. So what we have to do is we need to iterate over the rows and see how many rows are similar to that current row and how many rows are opposite to that current row. and the sum of that is going to be the candidate, one candidate. So for the row 0 I will do this operation, for row 1 I will do this operation, for row 2 I will do this operation. Number of rows which are similar to it, number of rows which are opposite to it. And how we can find that? And all the rows are having some cells, and those cells are going to have either 0 or 1. So if I try to make a key out of it, so that key will become concatenation of every cell value. So for this, keys can be 0 0 0, 0 0 1 and 1 1 0. So if I try to make it a string and maintain the counter of it, so I can directly say when I'm coming on 0 0 1, I will see how many instances are there in this grid and how many opposite instances are there in the grid. Instances are 1, instances are 1, instances are 1. So this map I can use to get the answer. And how do I get the answer? Just iterate over every row and just can give me the sum of similar rows and opposite rows. Here in this case, there is similar rows, I have 1, and opposite row I don't have in this grid. Here in this case, similar row which is this value, and opposite row is this value. So this and this will be added. 2 is going to be the answer. Okay, so I hope this approach is clear to you. Otherwise, just have a look on this section. And now let's try to discuss the time and space complexity of this problem. What is the time complexity? My grid is of size m cross n, and I'm iterating over every row once, and in every row I am comparing n cells. So yeah, I'm not going out of this iteration cycle. The time complexity will be order of m cross n, number of cells in the row. What is the space complexity? Space complexity will also be the number of cells. Number of cells are m cross n. Sorry, this time space complexity will be the same, m cross n, and the time complexity will be the same, which is this grid. We are not going out of this grid. Nothing special out of this grid we are doing. So this is the time and space complexity. Now let's try to code this problem. First of all, I would require a map which will store the number of instances every row, unique row is coming. That map, I will convert that current row to a string. So string and integer is going to be my map data structure. So this is my map, and first of all I will just store every single row in that map. For every row I will just map dot put key map dot get or default the key value. If that it is not there, I will just increment it. And what is the key here? Key is our string value, arrays dot toString this row. I will be converting this row to the string key. Okay, all the keys are stored, and now what I have to do is I need to get my answer, and my answer is I just need to iterate over this matrix again and see how many rows are equal to it and how many rows are opposite to it. So let's initialize a variable answer, and in the end answer is going to be returned for every row in this matrix. What I need to get is I need to get how many times this key is coming. So first of all I need to get the key. What is key? String key is equal to arrays dot toString row, and I also need to look for the opposite of key. Opposite of key means if the key is 0 0 1, then opposite of key will become 0 1 1 0. If key is 0 0 0 1, it should be 1 1 0. And how I can do this? I will just use the same function, and instead of row I will just pass the opposite, or let's give it a logical name, flipped row. And what is the flipped row? Private a new array flipped integer array row. Make sure you are returning a new array because I don't want to disturb my current input. And answer is equal to new integer of size n. what is an row dot length for int I equal to 0, I less than n, I plus plus, and in the end I'm going to return the answer, and this answer I is going to have opposite value than this row I. If row of I is equal to 1, in that case I'm going to have 0, otherwise I'm going to have 1. It should be question mark using a ternary operator here. If row 1 is equal to 1, I will use 0, otherwise 1. Okay, so this is the flipped row. Flipped row is here, opposite key is here, flipped key is here, and then what I have to get is answer. Answer is going to get answer dot maximum answer, comma, this value I can have. What is this value? Map dot get or default value of key plus map dot get or default opposite key. If that value is not present, return 0 number of time it is coming. Okay, so this should be my logic. Let's try to run over sample test cases. Seems to be working fine. I'm submitting the problem. It's submitted successfully. Hope you understood the problem. Thank you guys. Bye bye.